Good morning, campers. In today's lesson, we pick up with equation solving. And today, to be honest, we're going to be kicking it up a couple notches. So I'm hoping that you are pretty well caught up on the assignments leading up to this, especially solutions to equations and excuse me, and solving two-step equations. We're also going to be bringing in our old friends, the distributive property, and combining like terms. So this is a really important lesson where basically all of the practice that you've been doing since the shutdown began are coming together in one place. So buckle up and put your helmet on. We're going to get going. So let's see. There's a little baby Yoda for your enjoyment. The worksheet that you're going to be looking for is called Manipulating Expressions Within Equations. Okay. Here's a picture of it, and let's just jump in. Okay, so in the last unit, and again, we're not really breaking it up into units per se. We went from expressions right into equations. But a few lessons ago, we did a lot of practice with a combination of distributing and combining like terms. That was called simplifying complex expressions. So exercise 1 basically takes us back there. And it gives us an expression. And the first thing I notice is that the 4 is multiplying an expression in parentheses. So kids, that is the dead giveaway. That is a sure signal that we need to distribute. So I'm going to show you the preferred way that I like to set that up. And this should not be this should not be new to you. You should be familiar with it from previous lessons. So 4 is multiplying two terms. It's multiplying x, and it's multiplying positive 6. Okay? So again, we call this an area model or the box method or Punnett square. So 4 multiplied by x is 4x, and 4 multiplied by 6 is positive 24. Okay? So this block here becomes the binomial, right? Just a fancy word that means two terms. It becomes the binomial of 4x plus 24. So we can rewrite that part. Okay, take it out of the box, enjoy it. And then we have to make sure that we don't lose this part on the end, excuse me, of the minus 7. Okay, that was the distribute part. We still have 3 terms. 2 of them are like, so we're obligated, or we should, combine them. All right, and those terms are 24 and minus 7. So the 4x is the unlike term, and then 24 minus 7 is 17, and that's a positive number. Excuse me. Now, real quickly, I do want to run through that same expression using a different method that that I am totally okay with. And if you prefer what I'm about to show you, that's fine. The only thing that I will say is that you need to be really, really careful with your signs, keeping track of your signs. So this would be the way that I was taught at your age, probably the way that your parents taught and their parents were taught. So it would be more like this, right? Distributed property. Just drawing these arrows to connect. Okay. And then the next thing we would write would be something like this. That would be the first arrow that I drew is 4 times x. The second arrow that we drew was 4 times the 6. and then the minus 7 comes along for the ride. Then we actually perform the multiplications to get 4x. And then the second one is 4 times 6, so that's 24. And then the minus 7 is still waiting. And then as you can see, this expression here brings us to the same step here, and we still get the same final answer of 4x plus 17. So part B says evaluate. Okay, evaluate means two things. It means to substitute a number for a variable, and then it means to follow the PEMDAS rules until you can't follow the rules anymore. In other words, follow PEMDAS until it's as simple as you can make it. So we want x to equal 3. So let's come over to A, and then let's substitute. And then simplify. All right, so we just follow the PEMDAS rules, which would tell us to do the multiply first, 12 plus 17. So our answer from A is 29. All right, now we want to plug in x equals 3 into the original, which is this. All right. And then we'll compare answers. So another way to, I'm just going to write this over here. All right, so the very unofficial math definition of evaluate is basically to plug and chug. Plug and chug. In other words, plug the variable in and then chug away through PEMDAS until there's no more operations to perform. So here we go. Plug away. 4 times x equals 3. 3 goes in there. Plus 6 minus 7. Okay, order of operations would tell us to do this part next. That's 4 times 9 minus 7. Multiply next. 36 minus 7, which would also give us 29. So we got 29 in both expressions. That's a pretty good indication that we distributed and combined like terms correctly when we did the first part of A. All right, so if you want to take a minute. Excuse me. I'm just going to take a swig. Okay. Let's move on. Let's move on to exercise 2. Okay. Little typo here. These things drive me nuts, but we've now practiced, right? Not practices. That's ED, not ES. We've now practiced extensively, which just means a lot, with solving two-step equations. Sometimes we will need to manipulate, which just means change one side of the equation in order to produce two-step equations. Okay, so what this statement is saying in a nutshell is this, guys. For Math 7, starting in Math 7 and certainly going beyond, we are responsible now for being able to understand and solve more than two-step equations, right? So we're talking 3-step and 4-step equations. Those are possible in Math 7. Beyond Math 7 might require even more than 4 steps. Okay, so consider the equation. It may look familiar. This is the same expression as exercise 1. This was the same result as exercise 1 when we plugged in x equals 3. So manipulate change the left-hand side of this equation until it is simplified? Well, I'm not going to walk back through that. I don't really think it's necessary because we just did it in 1a. Okay, so if our work was good, let's just bring it down. It was 4x. Now I scrolled it off the page. Plus 17. That's what it was. All right, that was the left-hand side. Okay. B, solve the equation. All right, now remember, this is not an equation because it doesn't have an equals. That's just the left side of the equation. Well, let's solve the whole equation. So 4x plus 17 equaling 29. All right. Now, truthfully, guys, you should be able to handle this. We had a lot of practice in the previous lesson, which was called solving two-step equations. We did a bunch of them. Did a bunch in the classwork, and then you did several more for homework. So I'm going to recommend that you pause me here. Again, let me get another quick drink of water, and I want you to dive in and solve that. Okay? All right. Unpause. So what you should have taken away from the previous lesson is that we want to attack addition and subtraction first before we attack multiplying and dividing. All right, so the antidote to plus 17 is minus 17, and I have to remember to do that to both sides. So the 4x falls through, the 17s eliminate each other. They basically they add up to 0. 29 minus 17 is 12. Okay, now we attack the 4, which we see is multiplying. All right, and the remedy or the antidote is to divide by the same number. We get x equals 3. Now, we should have expected to get 3 if the expression is supposed to equal 29. All right, because again, that was the 2 parts of exercise 1. All right, part 1 was it's simplified, the left side simplified to 4x plus 17. And part 2 was, hey, let's check it to see what happens for x equals 3. We got 29 when x equals 3. Okay. Exercise 3. So if we use properties of numbers, if we use things like distributive property, remember the other 2 big ones were commutative, which allows us to move the terms around, and associative, which allows us to group terms using parentheses or to change groupings that already have parentheses. Then you will get equivalent. Let me go back to my pen. You will get equivalent equations. Okay, ones whose solutions are the same. So let's consider this equation. Solve this equation by manipulating, changing the left-hand side, and then check your original solution. So, all right, guys, I want to show you something here. Came up with this strategy. I don't know. I find it clever and amusing, but I don't know if it's worth like copywriting or something like that. But so several years back when I was teaching equations to my 8th grade students at the time, I came up with this. Find it here. Okay. What I came up with is this, and that is, there I am. Okay, so solving equations is, there. All right. Solving equations and doing it well, and getting that really satisfied feeling from solving equations is so sick. It is so sick. And here's what I mean by so sick. All right. S. Okay, the S in so. The S is to separate the two sides of the equation, right? You've seen me, you've heard me talk about like drawing a line through the equals. Oh, organize your workspace, right? So in other words, give yourself plenty of room. Make sure you have, hopefully you're doing it in pencil. You have an eraser nearby. You're not writing your work in gigantic letters. You are also, excuse me, if you feel that you will perform a lot better on the arithmetic stuff with a calculator, you've got a calculator available. So organize. All right. So the so in so sick is separate and organize. Okay. Now here's the sick part. The S in sick means to simplify. Okay. So simplify each expression separately. All right. In other words, the left-hand side, right, might be a fairly long little expression. And then what you're going to see, actually, once you hit 8th grade, is the other side of the equation isn't always going to be just a nice, happy little number sitting by itself. It's also going to be its own separate expression. All right, so the S in sick is to simplify each expression separately. Okay, the I is to isolate the variable using inverse operations, right? So the S in sick is simplify separately, and the I is isolate using inverse. In other words, isolate means simply get the variable by itself. Inverse means figure out the opposite operation, right, of what you see and do it in the opposite order. We've talked about that in past lessons. All right, so that's SI. Once you're through that step, you should have a solution. The C is always a good idea. It's not always required, but it's always a good idea. The C is for check. All right, check for correctness. And then the K is basically saying, well, did your check? Right? Did your check work out? Did it show that the solution works? If it didn't, you're going to kick it, right? If it checked, hopefully, you're going to keep it. So the K is to keep or kick your solution, right? So solving equations is so sick, right? Either that or solving these equations is going to make you so sick by the time you're done with them, but that part works too. All right, let me get smaller. Let me go back into my corner. Let me come back to the worksheet. Okay, so I'm going to pop back and forth just a little bit here to show you what I mean by the so sick. Ready? So SO, so sick, all right, means to separate and then organize your workspace. So here we go. 5 times x minus 7 equals 20. Okay, here comes the so part, right? S, separate. Okay, O, organize. All right, so I've written neatly. I've left myself what I hope to be plenty of space. And I also, I didn't write it, but I also have room over here where I'm already setting myself up for the check of the equation. Okay, so that's the so. So I'm separated and I'm organized. Okay, now here comes the sick part. All right, the sick part is simplify. Well, this here is not simplified. Why? Because I can see the need to do the distributive property. So I'm going to do that over here. Okay, 5 is multiplying x. 5 is multiplying negative 7. Okay, 5 times x is 5x. 5 times negative 7 is negative 35. Okay, positive times negative is negative. Okay, again, those sign rules are things that you need to know by heart. Okay, positive times negative is negative. So this left side now simplifies into 5x minus 35 equaling 20. All right, now staying on the left side, let's look at it again. I now have 5x and a minus 35. Okay, well, there's nothing left to distribute. Are there any terms I can combine? What do you guys think? Can I combine 5x and minus 35 into one term? All right, are they like terms? No, they are not. So I cannot combine them, which means that the left side is now simplified. Okay. So let me just pop over here just to remind you. Okay. So separate, organized. Okay, now I'm into the sick part. I simplified each expression separately. Next, I need to isolate the variable. Okay, so I need to find the letter, but I need to get it by itself. All right. But remember, I have to do it carefully. All right, I have to go carefully and strategically, and I'm going to use inverse opposite operations. So here we go. We're on the I step. Okay, so to isolate that variable, I'm going to do the opposite of the operations that I see in the reverse order that I see them. Okay, so the nearest thing to x is multiply, and the furthest thing from x is subtracting 35. So that's actually going to be the first thing that I attack. Okay, excuse me. So 5x falls through. The 35s basically neutralize each other. They go to 0. Don't have to write them. The right side is now 55. Okay, I have one step left, and that is to do the inverse of what the 5 is doing to the x. Well, 5x means 5 multiplied by x, or x multiplied by 5. So I undo that using division. Okay, so when I divide, I get x, because the 5's divide out, and 55 divided by 5 is 11. Okay? I get x equals 11. Okay, so here's where I am in the process. So it's so sick. I separated and organized. Then I simplified and I isolated. Now I'm at the C of sick. Okay, so the C of sick is to check. All right, here we go. So to check means to substitute and simplify. So here I go, 5, and I think 11 is the answer. So 5 parentheses, 11 minus 7. Does that equal, question mark, equal 20? All right, here we go. 11 minus 7 is 4. 5 times 4, does that equal 20? 20 equals 20. Okay, so there's the C part. S-O-S-I-C. That's my check. Okay, the check continues until both sides of the equation are down to a single number. All right, now the last part, K. I'm either going to keep the 11 as my solution, or I'm going to kick it. Well, if I get the same result, all right, in the check of my equation, like 20 equals 20, that's a really good thing. That means it should be the solution, and I will keep it. So the K in kick here is keep. So in other words, keep the solution. Okay, put a little check mark. Done. Done and done. Okay. All right. So quick little word from our sponsors here. Get a little swig from my Star Wars Force Awakens mug. By the way, I have to say that the Disney Corporation is not paying me for for pushing me for me pushing their Star Wars products, but I wish it were so. Okay, so very quickly. So for today's little secret message, little Easter egg in the video that you need to put in the Google form. Let's see. We're gonna go with. I'm gonna go back to my mixtape. Okay, and on the mixtape, this is going to be side 1, track 9. Side 1, track 9. It's a song by Jeff Beck and Rod Stewart. Jeff Beck and Rod Stewart. And the song is called People Get Ready. Here you go. Isn't that smooth? This song is so good. This song is so good. Very bluesy, very traditional, kind of gospel. So again, that is track 9. Track 9. Title, People Get Ready. Artist, Jeff Beck and Rod Stewart. Okay, let's turn that page over. Here we go. All right. Okay, so exercise 4. All right, we've got A and B. All right, I can tell just by years of experience looking at these that each of these equations is going to be, these are 4-steppers, okay? Because I'm looking at distributive property, all right? I can see that in there, all right? And hopefully you can start to see it too. Look at A, look at B. There's distributive property, okay? Then there's also a term left over, right? You see the minus 25? You see the plus 10? Those are terms left over. We're probably going to have to combine like terms, okay? And then from there, after those two things, now what we've got at that point is still a 2-step equation, okay? So it's going to be, it goes like this. Distribute, combine like terms, and then solve the equation, and then check it. Okay, those are the big 4 things. I have it broken up further in that So6. So here's what I'm going to do. And these you will find in the notes, okay? They'll be part of a Google slide, and they will be accessible to you at the time that you see this video. All right, now over here, I've got this. All right, so I'm going to come back to this. Okay, this is another document that shows my So6 strategy, except for it's broken down into all the details. So what I'm going to do is I'm going to go through the equation from the worksheet, but I'm going to pop back to this document so that if you're using these notes on your own to solve equations like these, hopefully it'll make sense as to what each of the steps is talking about. So here we go. All right, so sick. The SO in so, remember, is to separate. That was terrible. He can't even draw a straight line. How can I trust him to solve an equation? Okay, so separate and organize. Okay. Okay, so I'm organizing my space. All right. I'm setting myself up for a check, trying to make sure I have space for that. and I'm ready to dive in. So at this point, in the SO6 strategy, I have accomplished the SO, right? Separate and organize. Okay. The next step is the SIC part. All right. And it says to simplify each expression separately. Simplify each expression separately. Okay. Under simplify part 1, it says to distribute if necessary. Draw an area model somewhere off to the side. All right. Well, let's see if we have distributed property happening. And yes, we do. Okay. We have it right there. All right. So I'm going to grab some space maybe down here. You'll see when I start writing. But 9 times n plus 3. Okay. All right. 9 times n is 9n. And then 9 times positive 3 is positive 27. Okay. That's straight up distribute, guys. So this block right here turns into 9n plus 27 minus 25 is still there. Okay. It just drops through and waits. Equals drops through. 65 drops through. Okay. All right. Again, in the notes. Okay. So we did the SO part. Now we're in the S of SIC. And the simplify part 1 is to distribute if necessary. It was necessary. Here we go. Simplify part 2 is to combine like terms. All right. Now in the notes, I say to shape up all terms. That's the strategy where you basically use like you start with boxes and circles so that you have a visual on which terms are like which terms. If those shapes help you, then by all means draw them. Okay. The other way that we can shape those up is just to basically use like underlines. So in other words, 9n is an n term, but plus 27 is different because it doesn't have an n. And then minus 25 is also not like 9n, but it is like plus 27 because those are the two constants. Neither one have an n, so they're like each other. Okay, so I am still in the S part of SIC. I'm still simplifying. So the 9n, okay, has no more friends, but the plus 27 minus 25 combine, right? So if I add 27 and then subtract 25, okay, I'm still above 0. And as a matter of fact, I'm at plus 2. Okay, so 27 minus 25, very simply, is positive 2. Okay, the rest falls through. Let us look at our chart again. Oop. Okay, now we're on to the isolate step. Okay, it says isolate the variable with inverse operations. Isolate with inverse. Okay, so it says attack the constant next. All right, in other words, undo using add subtract. So let's attack the constant next. All right, here we go. The constant is plus 2. What's the remedy? What's the antidote? Oh, it's minus 2. But what we do to the left, we must do to the right. Okay, 9n. Patiently waiting, continuing through. Plus 2 minus 2 eliminates. 65 minus 2, 63. Okay. Just jump back to the chart. Next, attack the coefficient last. Attack the coefficient last. And you're going to undo that using either division or multiplication. And then a reminder underneath, it says to maintain balance. Maintain balance. That just simply means property of equality. Whatever you do to the left, you have to do to the right. Okay, so attack the coefficient last. Undo it using multiplication or division. Okay, well, coefficient is a word that means a number in front of a variable. Well, the number in front of the variable is 9. The 9 is multiplying by the n. So the antidote is division. Okay, so 9n divided by 9 is just n, and 63 divided by 9 is 7. All right, so at this point, we believe our solution excuse me, is n equals 7. All right, on our SOSIC chart, here's where we are. We're on step 5. We're going to check our solution for correctness. And it says to substitute for all copies of the variable with parentheses, then use PEMDAS. Okay? And we do not distribute in a check. Now, technically, you can. You can distribute in a check, but truth is, you shouldn't. Okay? So here's the check. We're going to rewrite the original. 9 times n plus 3 minus 25 equals 65. All right. Kind of spilling over into the other space, but I'll try to work around that. Okay, anyhow. So now substitute. So we think n is 7. So here we go. 9 times 7 plus 3 minus 25. Does that equal 65? That is the question to answer. All right, guys, it's PEMDAS all the way here. Okay, the next step is inside. So that's 9 times 10 minus 25. Is that equal to 65? Well, 9 times 10 is 90, and 90 minus 25, if you need a calculator, go for it, but 90 minus 25 is 65. So that checks because the two sides are equal. And then the last thing, the last letter, the last step, step 6 is K. Keep it or kick it. Well, does your check check? Well, it does, right? If it checks, keep the solution and circle it on the solution side. If it doesn't check, kick it, right? Kick it out. But the first thing you should do, though, because I've seen this and I've done it a whole bunch of times myself, sometimes if your check doesn't check, you made a math mistake in your check, right? In other words, that solution could be great, but you just made a silly mistake when you checked it. So first, recheck your check. Then, if the work in your check looks good, then recheck the work in your solution. Okay, so it gets a little bit, it does get a little bit sketchy if the check doesn't check, but I think we're good. So at this point, I should be circling n equals 7, even though I did it earlier. Okay, I got really excited and circled it too soon. All right, let's go to B. Boom, done. Okay. All right, if your head is spinning, pretty rapidly right now. I totally get it. I totally get it. And that's why I'm taking the time to make these videos and to give you guys. Oh, and by the way, once you submit the form that you watch this video, just as a reminder, the video is not gone. It's not. It doesn't disappear from your ability to see it. It's also sitting under a resources link, so you can watch this as many times as you need to, if it'll help. All right, cruising. Oh man, I don't understand when. See, isn't that weird? It's like all the ink. Sometimes it all sticks to the page, and sometimes it just has a mind of its own. So, don't mind me. I'm just trying to clear out stuff to make room for the last part. This is the last. Yes. Okay. Exercise 5. Here we go. Oh boy. Holy free holies, Batman. This is all right. This is, I guess I would still kind of call this a 4-step equation. Both of them, each of them look to me like they're 4 steps, but they're a little bit harder 4 steps because they not only have a distribute step, they actually have 2 distributes. Each one has 2 distributes. All right, so here we go. I'm going to separate and organize. So go back to red. Separate. Okay, organize, which would be, set up your check. Okay, here we go. So 5A, here's a distribute. And then here is another one. Okay, so 4 times x minus 3. I'm going to try to squeeze them down here. So 4 times x minus 3. All right, well, okay, so 4 times x is 4x. And 4 times negative 3 is negative 12. Okay, so this part becomes 4x minus 12. Okay, we got more. Got positive 2 times the quantity 3x plus 4. Okay, 2 times 3x is 6x. And then positive 2 times positive 4 is positive 8. I apologize. That's kind of small and more than just a little bit messy. But so the second part, the second distribute block, became plus 6x plus 8. Equaling 76. Okay, so now, so we separated, we organized. We're in the simplify. We're in S of sick. We're still simplifying because this left side of the equation ain't simplified yet. All right, it can get smaller. It can get simpler, and that simplify step is to combine like terms. So 4x goes together with plus 6x. Separately, minus 12 goes together with plus 8. Okay, so 4x plus 6x make 10x. All right, and then negative 12 plus 8, well, if I start 12 below, if I add 8, I'm not going to make it back to 0. I'm only going to make it as far as negative 4. Okay. SOS. SOS, right? By now, that's probably about what you're thinking. SOS, right? Help, emergency, rescue me, save me, SOS. SO, all right, separate, organize. S, simplify, okay? All right, now we got to get the ick, all right? The rest of it's the ick part, right? Isolate, check, and keep or kick. So let's isolate. We isolate by undoing stuff, all right? We attack with the opposite. So we get 10x equaling 80, right? Because the 4 is eliminated. 76 plus 4 is 80. Last step, undo the multiply using division. So divide both sides by 10. X is 8. Or so we think. Now, I'm going to be honest with you. The spacing on this page, unless like you are a really tiny handwriter, and I've got a few of those in my classes. And so as you're listening to this right now, you know who you are. You're probably doing fine on space. If you write normal human size or a little bit bigger, you're going to have a tough time with space here, I'm just saying. So here we go. We think x equals 8. So 4, I'm going to do my best, times x minus 3. So that's going to be 4 times 8 minus 3. Okay. Now, as I plug in, I go plus 2 times 3x plus 4. Well, that's this right here. Let me put a highlight on it. Come on, highlighter. Right there. Okay. So I'm substituting 8 into that part of the expression. Right there, 3x. So the 8 goes into 3x, which means 3 times 8. All right, so that part I kind of did in my head. So I'm just going to jump into the fact that this is 24. Okay. And then I still have plus 4. And again, as you can see, I'm like really sneaking into that other equation. I'll have to figure something out here. But anyhow, does that equal... That's horribly, terribly difficult to read. So hold on. Come on. Come on, pen. Okay, question mark equals 76. Okay. All right, I told you this is like really, really tight space. Whew, here we go. Inside out. We got to go inside out with PEMDAS. So 8 minus 3 is 5. So that's 4 times 5. Okay. Plus 2 times what? Well, 24 plus 4 is 28. And does that whole mess equal 76? Keep going. 4 times 5 is 20. Plus 2 times 28 is 56. Does that equal 76? Well, yes, it does. So our check checks. So we K. So the C is check. The K is keep. So check it, keep it, circle it, done. Okay. All right. Last one. Okay. So again, I've got 2 distribute blocks, and let me go to another color. Let's go green. Nah, we'll go blue. Okay, so I have a distribute block here, and I have another one right there. Okay. Let's see if we can just set this up with our little arrow helpers, right? So let's try this. So, okay, 2 times n. Trying to find the first spot where I have room. I'm going to go probably here. Okay, 2 times n is 2n. The next arrow is 2 times positive 6. Okay, that's plus 12. Okay, now this one, got to be careful. This guy's right here is negative 6. That's a negative 6 times n. That is minus 6n. And then again, it's a negative 6 times a negative 3. Negative times negative, got to know that. Got to know that, stone cold. Negative times negative is positive. That's plus 18. Bring down the equals. Bring down the 38. Okay, so we separated, we organized. We are now still in simplify. We did the distribute part of simplify. Let's combine like terms part of simplify. We get that with that. Then we get the plus 12 with the plus 18. So 2n minus 6n, you got to watch those signs. 2n minus 6n is negative 4n. And positive 12 plus positive 18 is positive 30. And then that whole thing equals 38. Okay. Now I undo, add, and subtract. Okay, I do the opposite of the add. Okay, so this is minus 4n equaling 38 minus 30 is positive 8. It's just 8. Now I undo, multiply, and divide. Well, to undo multiplying by negative 4, I divide by negative 4. Excuse me. 8 divided by negative 4 is negative 2. All right, let's check this. Okay, on our check, here we go. So going back to the original equation on B. So 2 times n plus 6. So 2 times n, we think, is negative 2. Okay, then minus 6 times n again, which is which again is negative 2. Boy, it's so tight, right, guys? Negative 2 minus 3. All right, I'll bring down the equals 38 when I write the next step. I just plain don't have room for it. So, all right, here we go. Inside of parentheses first. Negative 2, add 6. So it's 2 below. It warms up 6 degrees. It's now 4 above. So that's 2 times 4 minus 6 times. Now, inside the other parentheses, excuse me, that's like it's 2 below, and then it drops 3 degrees. Okay? That's negative 2 minus 3. It's not multiplying. It's just negative 2 minus 3. Well, if it's 2 below and it drops 3 degrees, it is now 5 below. Okay, now try to squeeze in my, does that equal 38 part? Okay, here we go. 2 times 4 is 8. Now be careful. This second product is negative 6 times negative 5. It's a negative times a negative. And again, that sign will be, please get it right, positive. Negative times a negative. This is multiplying now. So that turns out to be positive 30. Negative 6 times negative 5 is positive 30. Well, we're looking pretty good because 8 plus 30 is 38, yo. And the check checks. So the K is a keep and not a kick. So it's a circle. And this stuff is so sick. Right? This is like the sickest thing you will do as a 7th grade math student. All right. So again, this is pretty heavy duty. I get it. And I know this is a long lesson and I get that. Excuse me, but the time will be well spent, and the practice that we get will be well spent, and it'll serve you in problems moving forward. And so, anyhow, I'll be quiet. Look for the homework called manipulating expressions within equations. Make sure you also look for the SOSIC notes, and also the partial homework key. Don't forget, is released with every assignment to give you more examples. I hope you have a great day, and until the next office hours, peace.